Good afternoon, everybody. My name is Sylvia Dieckmann. Welcome to this talk about Google Maps and Flutter. To get you started, this is built as an intermediate talk. It landed a little more on the beginner side. If this bothers you, feel free to walk out, but I hope you get something out of it anyway. It's always something to learn. So let's see. We have a pop-up here that should not be here. All right, much better. I'm a freelance mobile app developer. I haven't always done mobile app development. I started in the back end, did a bunch of different things. But for the last few years, I'm almost exclusively working in Flutter. I spent my time between South Africa and Germany, which means that aside from soccer, I also had to become a rugby fan. And I'm fairly involved in the Google developer community. I used to lead the Cape Town chapter. I'm a GDG expert. And I'm also a really proud Flutterista. Flutteristas are outside. What I want to do here today is I want to build a demo app with you. If any of you knows me, you know that Christmas trees feature big in my life. So think about delivering Christmas trees. The feature set that I want to include is I want to have geocoding of addresses. So that's turning an address into latitude and longitude. I want to have customized map markers. I want to display the routes. I want to calculate distance and driving time. I only talk about that in passing. But the kicker is I want to have all of this in Android, iOS, and the web. So that is part one. And then in part two, I'll briefly talk about what we can do when things don't quite work out as expected. And we have to think a little beyond the packages that are out there. So let's look briefly at the Google Maps platform, what we have here. So we have the Google Maps platform is basically a family of cloud products. It's like a huge thing, and who knows what's in there. Google handles it well. That's in the cloud, and then on the device, we have our Android, our iOS, and our web browser. We have different ways of interacting with the Google Maps platform and with that family of products. The preferred ones is through the native Maps SDKs, and they're available for Android and iOS. For the web, there is no native SDK, but there is a Maps JavaScript API that fulfills kind of a similar role. And then in addition to that, there are a ton of different APIs. I think there are about 23 or so, and they do kind of all kinds of different things. Pollen count, tiles, 3D animation, whatever. So what's interesting is in this context, the native APIs for Android and iOS are free to use for me as a Flutter developer. The cloud APIs are charged per click. So anytime you want to build a Maps demo, you have to do a few steps first. First is you need to create a cloud project with billing enabled. You might not get charged if you're below the free threshold, but you need to have billing enabled. Then you need to enable a few SDKs. So in my case here, it's Maps SDK for Android and for iOS, and then the Maps JavaScript API for the web and the Directions API. I might also use the geocoding API. I'm not sure about that, but at least kind of a handful of APIs. And next is you have to generate an API key, at least one, but ideally you should have one for each platform because the API keys, as you might know, should really be treated as passwords, so they should be protected. And the best way is to tie them down on the cloud side and basically allow use for a certain platform only. And that's so what I do usually is I create an API key for each platform. That was prerequisites. Now let's look at the project setup. I'm using 3 different packages for this demo. The Google Maps Flutter package, provided by Google, and then 2 auxiliary packages, geocoding and Flutter polyline points. To get them to work, there are a few setup steps again you have to do. The first on the Android side is you have to pin down the minimum SDK version. Now that's not such a huge hardship because the last time I checked, the current default seems to be 21. So kind of pinning it to 20 or up is not so horrible. You also have to add your API key to the Android manifest to make it available to the underlying platform. You can just drop the string in there, but again, this is a little bit of a security issue because it is kind of a key that you should protect. So one recommendation is to use Flutter run Dart-define, and basically pass it in as you run your project. You can use the secrets Gradle plugin. It works beautifully. I tried it. The problem is that you will also need the same key later in your Flutter code, and the Gradle's plugin does not help you there. It only helps you on the Android side. That was Android. Now on to iOS. We again have to pin the platform to 14 in this case. We have to set up a little more plumbing code to make Dart-defines work. I put it on the slides here just for reference. I'll share a link to the slides afterwards. But really, somebody has written up a really nice description here, so I'm not going to talk you through the steps in detail. This is the steps. Let's skip that. And let's go to the relevant one. This is your app delegate Swift file. So that's basically your entry point for an iOS project. And there you have to import Google Maps and then provide the API key to your GMS services. So again, you could have just pasted in the string, but I'll do it the proper way and use Dart-defines for this with the plumbing that I skipped on the last slide. Last but not least, the web. Here I'm loading the Maps API, again with the API key. And I'm using that as a script tag. Nowadays, Google recommends to use a bootstrap loader script. When I tried that a few weeks ago, I ran into some issues, but it might well work now. Right, so that was the setup. The first step I need to do now is create a blank map widget. So this is like my top level view. I decided to use a stateful widget. In the state, I will keep a little bit of extra state about my markers and so on. And then the only thing really in this widget is the scaffolding with a Google Maps object. And Google Maps is provided by the Google Maps Flutter package. This Google Maps widget can get a list of different arguments, but are really two that are at the minimum interesting to me: on maps created and on initial camera position. On maps created allows you to get control of a maps controller. So this controller is created by the Google Maps widget, but then it gets passed out, and I can get control of it and save it and then use it later to, for example, interact with my markers or my polyroutes or so on. And so that's what I'm doing here with this callback function on map created, on map created. The initial camera position just tells me tells the Google Maps widget what part of the map to show and how to center it. And I'm giving it here a center position, and this happens to be the latitude and longitude of this location here, the city cube, and a zoom factor. So I think I just used 14 for, it looks good. And so this is what we get. This is Chrome here. We have our map, no marker yet, just a plain map centered on Macedonia and with a reasonable zoom factor. And you know, that is your choice. That map was nice, but it was a bit boring, so the next step would be to add a marker. I chose to keep my markers in the state of the wrapper object, this demo view. So I have a list of markers there, and every time I create a new marker, I just add that to the list. The way I create a marker is I use the marker class that's provided by Google Maps, Google Flutter Maps. It needs a unique marker ID, a position, and optionally an info window. The info window is the piece that pops up when you click on a marker that might show you extra information, for example, about this address. So once you have this marker, you add it to your list of your stateful widget, and then hand that list as a set, actually, to the Google Maps widget. So this is how it looks. I have my Chrome here on the left, Android in the middle, and iOS on the right. The markers look pretty much the same. They are kind of centered where I wanted it. So first one here, I just centered on my home location. And then you have a pop-up. The pop-up looks quite different on the different platforms. If this bothers you, you would have to write your own widget to display, which is quite a tricky enterprise, but it can be done. So far, we only have the red pin. So now I want to have something slightly more customized. And it turns out that the marker object that's provided to me through the Google Maps package contains a final argument icon, or an extra argument icon, which can be a bitmap descriptor. Now, default is the red pin, but you can modify that bitmap descriptor. This is what I'm saying here, what I'm describing here is the marker is generated by the underlying native packages, not by Flutter itself. So unlike normal Flutter widgets, I don't have complete control over it. That is a little bit of a disappointment, but there's a talk tomorrow afternoon that goes a little beyond what I'm showing here and actually shows how you can really write your own widget. I think it's tomorrow at 12. I'm certainly going to be there. So if I stick with what the Maps package provides me, I basically have three options. I can use a customized default marker and basically modify the color, and I do that with Hue. Or I can upload an asset. I can put a customized asset into my project and display that as an icon. But in this case, for example, I would have to build all the different colors that I need. I would have to kind of preload these assets beforehand. Or the third one, which I like best, is I can actually dynamically generate this bitmap. And the kicker is I can actually do it from a material design icon. Now, I'm not a designer, I have no artistic skills. Creating an asset scares the bejesus. So I'm always grateful when I can use somebody else's art. And I was really happy to come across this solution here. As it turns out, a material icon is just a pointer into a character set. So all you need to do is find the character code that represents this icon, and then basically write it like text with the corresponding font family onto a canvas. And you can write a single icon on it, you can stack these icons, you can give them different sizes, different colors, and you can do all of that dynamically. It's an asynchronous call, but it can be done dynamically. I wish I had come up with this, but I got inspired by a really cool blog post that describes this technique. And so once you have your customized bitmap descriptor generated from this material icon, you can then just hand that to your map marker and paint it again on your map. So this is like the icons that are generated 4 times magnified, just to give you kind of an idea. I wanted to show the status of an order kind of in a graphical style. And so I ended up stacking 2 different color-coded icons on top of each other. And this is, by the way, this is like really a cool thing for me. This is like absolutely done without any art and work involved. Right, so this is, I showed you the magnified version. This is how it actually looks. Here is my little Christmas tree in the middle of each map. And again, there used to be some issues with different color shading especially on iOS. I think a month ago or so, the Maps team has published a new version that overcomes this. So it's now kind of, the markers look absolutely identical. There's no more platform differences. So for the markers, now we move on to address lookup. There are a few steps involved here. Number one is I have to kind of give the user a chance to enter an address. That's standard Flutter. I'm not going to talk more about this. But number 2 is converting that address string, something like, I don't know, Messecue Berlin, Hardenbergstraße, something like this, into a latitude and longitude coordinates. Number 3 is adding the new marker at these coordinates. And then I'm only at number 3, okay, recalculate the bounding box. The bounding box is important to decide what to display on your map. So if you have a new marker added far, far away, you want to rescale your map and show all the markers in your view again, and that hopefully happens automatically. So first step is to recalculate the box, and the second step is to actually scale and center the map. So this is more or less the code that does all of that. Up here we have step 1, converting the address to lat long. Next one is creating the new map marker. Next one is calculating the new bounding box. And then finally, using that new bounding box that we just calculated. If I want to break this down a little bit, this was the first step, converting the address to lat and long. Here I'm using a new package, a geocoding package. And it provides me with a function location from address. You take an address, it's an asynchronous call, and you get back a list of locations. So one thing you notice quickly when you work with all of these packages, each package has its own notion of a location. The Google Maps Flutter package uses lat long, and I decided to stick with that. This package uses location. The next one used, I think, lat long points. They all have some version of lat and long, but you have to do a little bit of conversion every time from one to the other. But here in my case, I'm starting with my asynchronous call here. Getting the first result, you get a list back. Just to keep it simple here, I didn't put error handling on this, but you have to be able to, you have to catch your exceptions. This throws exceptions, for example, if you're online. And it will also return 0 or several results if your address isn't unique, for example. So you have to be a little bit resilient here. In most cases, you just take the first element and then you convert the location object back into a lat long object. Step 2 is creating the new marker, but we've discussed that already, so I'll skip this step. Step 3 is calculating the new bounding box, and that's fairly simple. All we have to do is we now have a list of latitudes and longitudes, and we just have to get the biggest and the smallest lat and the biggest and the smallest long. I'm probably getting my gestures wrong here, but you know what I mean. And so that basically gives you the corners of all the maps on your screen. This is not really anything map specific. This is just very, very simple math. And then step 4 is recentering the map. And this is where the controller comes handy that we grabbed early on. Because with this controller now, I can tell the controller to use the new location, or in this case, not a single location, but a bounding box with a little bit of extra margin. That's the 100 there. And then animate the transition. So that takes care of all the, kind of the slick zooming and everything. Let me see if my demo works. Let's put in an address, Kreuzberg, it's a borough in Berlin. And you saw how the map zoomed out, put the second marker on somewhere in the center of Berlin, and then zoomed out to show both. Now let's look at something really far away. Let's say Vienna. Okay, again, the map took care of the zooming and the animation. As I mentioned, I'm using the geocoding package for this part. That has the advantage of using the native Maps SDKs for Android and iOS, which means it's free for me. It has a disadvantage that there's no web support, and we'll talk about this in the second part a little more. The last thing I wanted to do is I wanted polylines. That's kind of the routing information between 2 points. So here I'm using a new package again, the Flutter Polyline Points package. Try to say that 5 times fast. And I'm accessing a new cloud API, the Directions API, through this package. This Flutter Polyline Points package gives me a list of waypoints, each of them coded as lat-long points. And in addition, also the distance and duration. I'm not showing you here how to display the distance and duration, but you get the idea, I hope. And then from this list of lat-long points, you can then generate a polyline package, a polyline object. This is now provided by the Google Maps Flutter package, and it's very similar to the markers object. I'm overusing, or they are overusing the word waypoints a little bit, so you have to keep this apart. We first have the Flutter Polyline Points package that gives me a list of waypoints, but these are not the waypoints I'm then getting later in polylines, or one gets turned into the other. It is a bit confusing, but I hope it gets clear when you look at the code. Oh, and finally, we have to put the polylines on the map, of course. So this is the code. This is the first step here. I have the Polyline Points package. And I use a function getRoute between coordinates, which gets the key, a start point, an end point, and the driving mode, or the travel mode. I picked driving here. There are quite a few more parameters here. For example, you can have like intermediate points or waypoints or so. Anyway, so you send this request off. It's an asynchronous request, and you get a polyline results back. Now, this polyline result contains waypoints. Waypoints have the format is, it's waypoints is, I think it's lat-long points, which again have to be converted into a lat-long object. That's done here. And then with this list of waypoints, I can now generate a Google Maps Flutter polyline object. Now this should look almost identical to the markers object because it is the same package and kind of the same style. A polyline object contains, again, a unique ID, some styling information, and rather than a single point, it now contains a list of waypoints. Now, once we have this new polyline, which we added to our state, so the state keeps a list of polylines, and then ask Google Maps to include these polylines into the next row of the map. And that's what we get. We have 3 points here, home, and then 2 maps points, and then we have kind of the driving instructions in between. This package used the Directions API, which occurs some costs. But the beauty is it also returns distance and duration. So in a longer app, I probably would have displayed, in a longer demo, I would have displayed those as well. And it allows you to do more complex requests. So for example, you can ask for alternative routes, or you can ask for kind of routes between 2 points with stopovers or waypoints, so you can map your entire route out, so you have options. So this is more or less the end of the demo, but I glossed over a few things. The Flutter Polyline Points package has some bugs, and one of them that was a little bit annoying for me was that when I use multi-stop routes, the direction and duration wasn't calculated correctly. The geocaching plugin, I didn't come across any bugs, but it doesn't support web, which was a big problem for me. So what do you do in this situation? Basically, I wanted to use this as an opportunity to dig a little bit deeper and talk about some strategies that in general we can employ at in this situation. So I want to make one thing crystal clear here. Now, I'm picking a little bit on these 2 packages, but trust me, I come in peace. I don't mean to point any fingers. I'm just using these 2 packages as examples of a very, very typical scenario that we all face. You know, the Flutter ecosystem is really awesome. The fact that we have we can lean on each other's work and we can share so much work is super helpful. I love using other people's packages and sharing my work, but sometimes somebody else's package is not quite solving our problem. And that can be a little bit intimidating as a beginner. You guys don't look like beginners to me, but still. Maybe you remember how it felt for you. So basically what I'm arguing here a little bit is like, we own these packages collectively. We have control over our own destiny. So we can go beyond and kind of twist a package into a shape that fits for us. So let's look at the two concrete examples. The Flutter polyline points package. This one is written by a single individual contributor. It's a really nicely structured package. It's quite easy to understand, I thought. And I really enjoyed looking at the code. What it basically does is it uses the web API or the directions API that's provided by Google Cloud's platform. And it basically uses HTTP to send this request off and pass the results. So the majority of what the package does is kind of take all the arguments, get the request together, send the request off, and then once the result is back in, kind of pick the results apart and hand that back to the caller in the correct format. And this is actually also where things go wrong. It turns out there is an issue already filed. Somebody found this before me. When you ask for a multi-point route, you get back several pieces of polyline segments, and each of them has a duration and distance. And the author accidentally only takes the first one and hands that back to the caller, not the sum of them all. So as it turns out, again, I'm not the first one to discover this. Somebody actually filed already a bug report and then made a PR. That PR is hanging there. And I looked at the PR, I found something else wrong with it. So I basically ended up forking this entire repo, making another 2-line fix and filing that new fork as another PR. I assume that it won't take forever until the author gets around to accept or reject or comment on these PRs, but at the moment, he or she had not had time to look into this, and I totally respect that. But I must assume eventually this bug will be fixed. In the meantime, I decided, no problem. I have my fork that's almost identical, except that it contains this bug fix. So I simply temporarily link to my own fork. And since it's a fork, it's already exists there as a PR. It already is on GitHub. I can just link to it straight. And one day I'll find out that my PR or the other author's PR has been accepted, and I will simply delete this line again and refer back to the original package. So that was the simple case. Now the more complicated case, geocoding. Now, geocoding package is not written by an individual contributor. It's written by a Dutch company called Baseflow, and they are heavy lifters. They are partnering with Google and have taken over maintenance of some of the official Google Flutter plugins. And it turns out that there have been people asking for web support for their package, and they have argued very well why they don't want to do that. The reason is that by Android and iOS use the native SDK, and with that, the requests are free. If they would support web now, they would have to use the JavaScript API, which would incur fees. And they feel that mixing a free and a for-fee service is not a good strategy. And I understand that. I think that's a very fair decision. And certainly I'm in no position to kind of prove them wrong on this. But it's not a technical position, and it's also a decision that I can say, I know the difference between paid and not paid, and I'm happy to pay the cost for my web users. I just, for myself, reserve the right to decide differently. So this is what I'm facing now. This one is the last package I showed you, the And the geocoding was a package, not a plugin. This one is now a proper plugin. The difference is that it uses the Dart platform channel to include to access native components. So we have our GeoPoints plugin here, and then we have the Maps SDK for iOS and Android on the native side, and the Dart platform channel in the middle. What's really cool for me is that this package has been written in as a federated plugin in a federated architecture. What this means is that in my Maps demo, I include the geocoding package. Now, the geocoding package is mostly a shell. It contains kind of a list of the libraries and so, but it is by all intents and purposes a shell. It refers to another package, the geocoding platform interface. This interface is important because this lists all the functionality that is exposed to the caller. And then it has like 2 or many other packages that each package implements, represents a platform and implements the platform interface. So this is kind of what Baseflow published. But it means that there can be other unendorsed community contributions as well. So you're completely free to write your own geocoding web package. As long as you implement the geocoding platform interface, your code can simply use this package, right? Now, this is really cool. This means that basically I can, for myself, add my own contribution and then continue writing my Maps demo as if nothing happened. That's exactly what I did here. I need to make sure I'm implementing the geocoding platform interface. And then I decided, I feel uncomfortable kind of second-guessing Baseflow's intentions, so I did not publish this. In fact, it's still a work in progress, to be honest. Everything else, the code has been checked in. This piece has not been checked in, and I probably will never check it in because it seems kind of my private decision. But it can easily refer to my private repo or my private code, as I have done here. And it basically just augments what they have done already. So that was a lot faster than I expected. What I hope I've shown you today is that Google Maps integrations are simple. There are many ways to get started, but I was quite happy with the combination I showed today: Google Maps Flutter, geocoding, and Flutter polyline points. There is so much more Maps functionality around that would be sufficient for many more talks, but today we'll stick to these. In general, whenever you can, try to use the native SDKs over the cloud APIs because it cuts down on costs. Yeah, it's plain and simple. And then the kind of the meta thing I hope I showed you, if any of you was ever reluctant to jump in and kind of second guess somebody else's work, go ahead and do it. Just do it in a respectful way. But basically, that's what Flutter is for. Kind of, we are all kind of controlling our own destiny here. And that's it. This QR code gets you to the slide deck with all the links and whatever I put in there. I'm a bit ahead of time, so do we have any questions? Or you can clap.